Hi, I'm Maxwell Rosenthal. I am a computer science and cybersecurity major here at Capital Technology University.
And I'm Ivan Mendez. I'm an electrical engineer major at Capital Technology. Here we have Arduino Uno security system that uses ultrasonic sensing to sense if there's a threat present. Firstly, as the baseline, as we read right here, this says the status is no threats, meaning that there's no one going through the sensor. However, when we cross a threshold, multiple things happen. First, the red light turns on, the buzzer sounds, a new system status happens, reading intruder alert. And last thing, the servo moves. Now, the servo could be used for multiple reasons, such as locking the door behind the intruder in case they need to be detained in a specific area. Within the code, as we can see, Maxwell is currently modifying the code to be better optimized. Maxwell, can you explain the code?
Sure, so let me just finish this comment real quick. All right, there we go. So, inclusions, we start with that. This is where we include our libraries, and from there, and probably best I angle this way, but whether or not the camera will see, we'll find out. But essentially, we start off by getting our libraries. We got a library to interact with the servo, to interact with the wiring, to interact with the LCD right here. And then we go through, we define some variables, we essentially create some numbers to go off of. Like here we can specify the tone of the buzzer, and if I just run this real quick just to get the newest version of the code up, and it should be done uploading. And now if I do this, you can see the tone of the buzzer is that. If I were to change the value, it would be something else, and I'll just change it to something else because we might recompile this by the end here. So essentially, we sort of set up the pin number. So each one of the pins on this Arduino right here go to something, and one might go to the buzzer, one might go to the LED, one might go to another LED, one goes to display, so on and so forth. It's actually depicted in that diagram right there. But so yeah, we just generally have some variables being declared, and then as we go through this is an embedded system. Every time you're dealing with embedded systems, you're dealing with what is essentially a loop. If you want to correct me if I'm mistaken, embedded systems act on loops.
Embedded, yep.
Yeah.
It's looping.
Yeah, they're all loop based essentially, or there's some kind of reactivity. But in this case, there's an overall loop going on here, and what's happening is every time it loops through, it runs some code, and essentially it's writing some code related to the display. It's essentially deciding on like the duration to do certain things, the distance from this thing, which is an ultrasonic sensor. So with sound waves, it sort of detects your position. So if the distance is within the sort of distance sensitivity range, you'll notice that it's going to turn red and the servo is going to change its direction. Now we have the ability to change this from anywhere between 0 to 180 degrees. And in this case, let's change it to 90 so that we'll see that changing this value right here will move it 90 degrees instead of 180. So essentially, whenever it's triggered, the buzzer will go off, and then the LED is going to switch to the other LED. And if you move your hand away, it does the exact opposite and just sort of moves it back to everything being default. So once that's done, essentially that's when the position that got updated gets written, and the cursor of the LCD gets reset to the initial position, so it's ready for the next pass. So compiling once more. And you can see it's sort of resetting whenever this thing turns off. But you'll notice now it was going from what was essentially here to here, or here to here. So now if we do it, you'll see it goes less of a degree than it did before. Okay.
Thank you guys.
All right.